Hi there. We are from the Portuguese Science Communication podcast, PCR, and we are here to celebrate the International Microorganism Day with a special edition of our program.
We would like to thank FEMS for the opportunity to participate in this event, and to do so, we brought you a very special guest.
It is only natural to celebrate this day with a conversation with a researcher that studies microorganisms, so we are very happy to talk with Raquel Leão, group leader of the Molecular Microbiology of Human Pathogens Lab at ITQB-NOVA here in Portugal.
Thank you, Raquel, for accepting our invitation to celebrate the International Microorganism Day and talk with us for a bit.
So thank you very much, José, Felipe, and Ricardo. It's really my pleasure, and it's an honor to be able to participate in this interview.
Okay, let's get started with the first question, and I will get right to the focus of this talk. And the first question is, what is the focus of your research at ITQB?
Okay, so at ITQB, my group is very much focused on a particular microorganism, a bacterium, that is named Streptococcus pneumoniae, or pneumococcus for short. And as the name suggests, it's a main cause of pneumonia, but it can also cause otitis media or meningitis. So a different spectrum of disease, from less severe to very, very severe and even fatal. And worldwide, the morbidity and mortality associated with this bacterium is very important. Having said this, what we focus in our group is not on the disease, but on the asymptomatic colonization. And so this bacterium lives with all of us in the upper respiratory tract, so more or less here, and most of us will be colonized several times over our life without having any symptoms. And we focus on this step on colonization because colonization is essential for three things. For transmission between hosts. If you are not colonized, you will not transmit. And these things I'm telling you can just think about SARS-CoV-2 because it will be the same. And nowadays people are very familiar with that. So if you are not colonized, you don't transmit. If you are not colonized, you don't get disease. And if you are not colonized, the bacterium in our case, the pneumococcus, will not evolve, right? So we divide our research in two main things. One is very related to public health policy. There's a vaccine nowadays that targets a subset of these pneumococcus. Not all of them, but a few of them, okay? And what we do in our lab is to do field work. We go into the community, we get swabs from people, exactly like you do for SARS-CoV-2 when we are trying to test people for the presence of COVID-19. And then we look at those swabs and we characterize the bacterium that's in there. And based on that, coupled with epidemiological data, vaccine use and demographic data, we can understand what the vaccine is doing on the bug and ultimately on disease. And you can also make the parallel with COVID-19. We all know by now that what happens in Portugal is not necessarily identical to what happens in Asia or in the United States or in Africa. So local epidemiology is very important. And we get data from Portugal and we share it among the Portuguese society. So that's one of the main focus. The other focus is a bit more basic research. Nowadays we know that we have not only pneumococcus in the upper respiratory tract, but several other microorganisms which are part of the microbiota. And if we understand how the pneumococcus interacts with other microbiota, we can use that information to find alternative strategies to prevent colonization. And so if we prevent colonization, we will prevent transmission, disease, and evolution, right? And so that's the other second line of research that we carry out in the group.
Okay, so picking your second line of research, I would like to ask you why it's important to study microorganisms as pathogens.
Well, I think that touches all of us, right? So when we think about pathogens, I think most of us will think about human pathogens, but it could be plant pathogens, animal pathogens, you name it, right? But pathogens, as the word suggests, it's going to affect our health state. And it's the main goal all societies. I mean, to live, we would like to live as much as possible, but in a healthy state. So by studying pathogens, of course, we try to understand how can we tackle those pathogens, how can we treat the infections. But here I'd like really to make a focus. To treat is good if you can, to prevent is even better, right? So if you can prevent disease, that's very important. So I think that's why me and many of us study pathogens.
So you've mentioned SARS-CoV-2, right? And that's the main reason why we can't do this interview like face to face. We have to use this new way of doing conversation. But since you mentioned it, I think we all agree that people now are more aware of the effects that the pathogens can have to us as a society. And by pathogens, I mean either bacteria or virus. But do you think now is a good time for us to, as a society, discuss changes in public health policies? Do you think people in governments are more open to it?
Well, definitely, I think so. And when we think, I mean, and here the focus, when you think about public health policies, it really means, in a very broad sense, anything that will affect health as a whole. So it could be obesity, depending on society, right? But now we are very much focused on infectious diseases. And I think this is what we are going through. It's definitely something very unique and extraordinary that will remain with us for our entire life. I mean, the experience that we are going through, not the pandemic. So I think this pandemic, as probably many of you are aware of, had been predicted for many times, because we had pandemics in the past, and they come from time to time, and we'll have pandemics in the future. And actually, in the WHO website, for example, for a long time, you would go there and you'd have the major threats, and you'd have the agent X. Nobody knew what was going to be Agent X. It was going probably to be a virus, but we didn't know which virus or which microorganism at all, and when it would come, and from where it would come. But it was predicted it would come, and so I think definitely what we are going through is having a tremendous impact in our lives, not only in public health, but in all our society. And I hope that a few things regarding infectious diseases and infection control will remain in our society, because these are some of those things we knew them for a long time, and they are very important. And one thing that maybe two key messages I'd like to convey when we talk about infection control is that washing hands, for example, this has been known for decades. That is the simplest, the cheapest, and the most effective way of preventing infectious diseases in general. And we know that, and that is true not only for hospitals, but also for infections going on in hospitals, but also in society. And although we know that for many, many decades, we still have a long way to go before population as a whole washes hands as frequently as needed. And the other thing that I think it's also very interesting is that the use of masks that we now all use, social masks or surgical masks, we know that, for instance, in Asian countries, this is a custom for many years. When we travel, we see very often Asian people with masks, and we don't know if they are protecting ourselves from potential infections they have, or if it's the other way around. But they used to use it. And this has been known also for decades, for over a century, that surgical masks or masks in face masks will help us protect transmission of infectious diseases, particularly respiratory infections in general. It's not only about SARS-CoV. It can be a common flu, can be influenza, anything. And so this is also a habit that probably we should keep for the future, and would also help us prevent infections. So one thing that I think it's an opportunity here, and that became very clear at the beginning, is that we really need to invest a lot in education. Education about microbiology, I think, in general, for the population, for our students, for our politicians and so on, has increased a lot very recently. but we should definitely invest on that. I think that's very important.
Yeah, worst case scenario, we'll learn from this and move forward with many other cases that may come in the future. I guess that's the main thing.
Mm-hmm.
Okay, so last year your lab participated in a simulation of an hospital outbreak, and you managed to identify the threat in record time. And this was last November. Am I correct?
Yeah.
So fast forward to the present day, we have the coronavirus pandemic, and it's a global outbreak. Although it is a virus, and your simulation was from bacteria, but can you tell us what kind of differences did you find in when comparing the simulation, the controlled simulation of the hospital outbreak to this global outbreak of coronavirus?
So what we did was very specific, because we are not the infection control team, right? We were assisting them in our simulation. We were assisting them in identifying the source of the outbreak and tell them in record time what was it, so that they can do their work. And so in the simulated outbreak, what we had were several samples. Some had been collected from patients, and suddenly a particular pathogen which was multi-drug resistant, was being frequently isolated from different patients in different rooms. And this was unusual, and immediately this rang the bell that maybe something was going on and this pathogen was being transmitted from patient to patient. And if that was true, what was the source of it? Who was transmitting it, or what was transmitting it? And so what we did as well was to get, in this case, environmental samples. So we got samples from the knobs of the doors, from sinks, and so on. And what we had to do was to extract total DNA, total genetic material, and compare it in record time and see how close was this DNA from the different samples. And we could identify in this simulated outbreak that environment, in this case, it was the environment, was playing a role, in the sense that, for instance, a patient would be admitted to a particular room, and the room was contaminated in the sink. So when people were washing hands, aerosols would form, and in the end of washing hands, you might end up with your hands contaminated, and then auto-inoculate yourself and get the infection. And so what we did was, in record time, to obtain this information and give a call to our infection control specialist and tell, this is not a coincidence. All these bacteria have a common ancestor and they are being transmitted. And that's the key information they need to decide how they are going to tackle the problem. Because if it's a single source, now they will have to control that source and prevent dissemination. And that's very different from imagine that and every single patient is coming with a bacteria that is close to another, but they are all different. Then you'd have to tackle in a different way with this problem. How does this compare to the global pandemic? Well, when you look at the global pandemic, this, which is a huge problem in Portuguese hospitals and hospitals worldwide, the control of nosocomial infections, seems simple, I would say, in a way, in the sense that it's confined to a hospital, and you have a physical confinement, and so it's very difficult to deal with. But compared to the SARS-CoV-2, I think it's much simpler, of course.
So now we have one question that usually we do in our podcast, where you have to choose one option. And you have already talked about the main lines of the research from your group. But now with all these pandemic problem, we know that you are also doing some job related with COVID diagnostics. So our question is, it is harder to deal with COVID samples or with PhD students that did not have their coffee?
I don't know. I can deal with both
Trick
of
question.
This is bad for us.
I cannot complain about my PhD students.
There's time for one last question. And let's put it this way. I think we can consider pathogens as the bad guys of microorganisms. Why would you say that in science, as in movies, the bad guys are always the most interesting characters?
Well, to be honest, that's a tricky question because you are already implying something that I might disagree, right?
Yeah, I'm happy that you disagree with me.
I think bad guys are always the most interesting ones. I'm not sure. I'd have to think about it. I think it will depend.
The bad guys, yeah, I did this. Yeah, it's like they're always the ones we're searching for. More in science, but you can actually see the same thing in movies.
Yes, because the bad guys do us harm, and nobody likes that, right? But actually, you will find some scientists, some scientists that will focus on the good guys, and from where you can learn a lot. And if you think about, for example, the model organisms for bacteria, they are good guys. It's Bacillus subtilis and Escherichia coli. They are harmful. They don't do us any harm. And in fact, that's one of the reasons, not the only reason, but one of the reasons why they are model organisms, because they are safe.
Yeah, so we basically need the two of them to move the story forwards, either in science or in the movie. Basically, you need to look for the bad guy and for the good guy.
Yes, and now in changing just slightly a little bit the focus, but that question is important, particularly for a day in a day like the International Microorganism Day, is that most people know that bacteria exist and microorganisms exist, but many people will associate them to bad things. And we know that we need bacteria to be healthy, and we need bacteria for many things in our lives. And it's not only about disease. So although the bad guys catch most of the interest, I think we have really to promote the good guys in this case.
I would like to finish this conversation, let's say. I would like, again, to thank you for accepting this invitation, and of course, thank you for this interesting conversation. You guys can know a little bit more of Raquel's work in a link that we're going to leave here, but it's at ITQB's website. You can also check our social media to know a little bit more about our podcast. And I think that's it. We'll wrap this up. See you soon, and have a nice Microorganism Days, guys.
Thank you. Bye.
Bye.